My name is Maria and I'm standing here with Philip. Hi and welcome.
Hi, thanks.
Can you briefly introduce yourself and tell us a bit more about your research topic that you're doing at the Carnegie Mellon University?
Sure. I'm Phil Koopman. I'm a professor at Carnegie Mellon University, and I've been doing self-driving car safety for about 20-some years, back in the CMU team, back in the automated highway system days.
What changed in these 20 years, more or less?
Well, back 20 years ago, everyone was chasing the cool demo.
Okay.
But back in the 90s, they were able to drive. So the CMU team drove from Washington, D.C. to San Diego, 98% hands off the wheel.
Okay, so why did it change now? Why can't we do it like now?
Well, for the last 20 years, we've been working on that last 2%.
Okay.
Okay, and the last 0.2% is going to also be hard.
Okay.
And the problem is that the easy stuff is easy and the hard stuff is hard.
Like always.
Like always, right. And so now what you see is the industry working on the last few percent, because that's the hard stuff.
When can we expect the next, let's say 1% or something like this?
Who knows, right?
Who knows? Okay.
Who knows?
So we're still working on the.
We're working, but the problem is, it isn't about the last 1%. It's about the last 0.0000, a bunch of O's, 1%.
Okay.
Because safety isn't about the 10,000 times you see the kid and don't hit him. It's about the one time you don't, right?
Yeah,
and
true.
so it's all about the hundreds of million miles between major mishaps, and that's a lot of zeros. Or in the safety business, we say it's a lot of nines, 99.9999, bunch of nines.
Yeah, true. You're presenting two case studies. One is about making autonomous vehicle road testing safe.
Yes.
Can you share some insight with us?
The big thing there is that people tend to focus, when they talk about testing safety, they tend to focus on whether or not the autonomy is sufficiently mature. But while you're testing, the safety of everyone else on the road isn't about that at all. It's about whether the safety driver is able to pay attention and able to intervene in time. And we've known, again, for 20 years, we've known that that's hard for humans to do. It's really hard for humans to pay attention. So if you're going to be out there on the road testing, you have to have really extraordinary measures to make sure that human supervisor is going to be there when they're needed. And so that's what that talk was about, exactly why that's so hard, and how it isn't about, is the autonomy ready or not? It's about whether the safety driver is ready.
So wouldn't it be better just to have a machine or like AI doing the testing instead of humans who can't, like you said, or who can't not really focus, but for them it's hard to focus and pay attention to all the details?
Well, machines are good at focusing, but they're really bad at dealing with stuff that nobody thought of.
True.
Okay.
True on the other hand,
so there's two ways to do it. One is to put the human out front for the weird stuff and the machine in case the human makes a mistake. And that's more the idea of ADAS backing up the human.
Okay.
And that plays to the strengths of the human and the computers. But the problem is the human's still driving. And if you want the human to not drive, now, if you want the human to supervise autonomy, you're sort of doing it backwards, because you're asking the autonomy to do something it's not good at, which is handling all the weird stuff. And you're asking the human to do something it's not good at, which is paying attention to a long, boring task.
Okay.
So this is why the combined system that way is so hard. Eventually, I hope we get to fully self-driving cars. But until we're there, we have this sort of awkward teenage phase where we're trying to ask the humans and autonomy to both do something that's really hard for them.
So we have to find a balance in the two of them, to get.
We have to find a balance. We have to make sure we're not putting the public at risk while we're still testing and developing the technology. Someday it'll be great, but we're not there yet.
Okay, and we have a challenge up your session today discussing whether driving as a human driver is good or safe enough. Can you share something, or what do you think about that?
Oh, I think humans are much better than the current dialogue we'd give them credit for. So a typical human is about, rough numbers, 100 million miles between fatalities.
Okay.
That's a lot of miles. And that number includes all the drunk drivers and all the speeders and all the distracted drivers.
Okay, wow.
So if you take out if you say a driver who's actually doing what they're supposed to be doing and paying attention and not compromised, it's maybe twice that. So that's actually really impressive that humans are that good. And so that sets a high bar. And if you add ADAS behind them, the humans get a little better. Yeah. So the bar keeps raising for how good autonomy has to be as good as a good human driver as opposed to a bad human driver.
Because you never know. I mean, there's, like you said, there are speeders, there are people who don't pay attention with the little kids and so on and so on. Yeah. this is why this challenge of your session is about.
Right, so the autonomy can address those human failings to a degree, but the bar is set higher than I think a lot of people really appreciate. Humans are actually pretty good. Now, there's a lot of fender benders, a lot of lesser stuff. Maybe the autonomy will help with that. And again, ADAS can help with, you don't need full autonomy to help. ADAS would help with that as well.
Okay. And then, let's look at one of the hot topics that we are talking at the conference today. AI, will it be the sole solution for autonomous driving, or do we need other trends to look out for, or other challenges that we were facing right now?
Well, if by AI you mean machine learning, then you need that plus other things. And I think all the vehicles you're seeing on the road that are really going to be practical have a bunch of other things. Okay. Because if it's pure machine learning, if it's end-to-end machine learning, I have no idea how you could possibly validate that that's safe, because you have no idea what's going on inside. So the more sophisticated vehicles have some machine learning and some other things. And in my view, that the smart way to do things is to make everything you can not machine learning, or to make a non-machine learning safety check that guarantees the machine learning is on a short leash. There's a few things that are machine learning, and there you're going to have to do special things like do aggressive brittleness, robustness testing, things like that. So it's definitely a hybrid approach. Okay.
You just spoke about the safety issue or the safety aspect. And that is the other talk that you're having at the OSS 5 about machine learning and perception stress testing.
Yes.
Can you share some insights with us?
Sure. What we found is that machine learning used for perception often has a lot of failure modes that people didn't anticipate. And so people design tests for autonomy saying, well, a human would make this mistake, so let's make sure the autonomy doesn't make that mistake. And that's fine, but what we find is the machines make mistakes that a human would never make. Okay. And finding those is tough, but I can give you an example of the kind of things. So we have a way that we inject some noise into the image, and we find that very small changes fool the machine learning. And this is not malicious, we don't reverse engineer, we just put in some noise. Okay. And we find that the machine learning will stop seeing some kinds of people. Okay. How? And it just a few pixels changing, and all of a sudden that person just, the machine says it's not a person, it's something else. We don't know what. Okay. And that's a problem because when a person looks at the images, they see, you can't even see a difference. Yeah. It just looks a little grainy maybe, and where'd the person go? But the thing that really surprised me was it actually goes further than that. It isn't about noise sometimes making people go away. We actually found it identifies systematic problems. Okay. So it is not just any person going away. It's women with short skirts and legs and bare legs. They'll disappear, but it'll see everyone else around them. Or children next to adults will disappear, but children not next to adults will be just fine. So it's what we think this means is the machine learning wasn't trained on those special cases. Yeah. So we're able to identify the gaps where the machine learning is weak by adding noise. I'm really surprised it turned out that way. We never expected it, but that's why research is so cool, because sometimes you have these unexpected results. So we have built a tool system that goes through and automatically stresses perception systems and identifies these systematic failures so that then the teams can retrain it and plug the holes.
Can autonomous driving in some way help us solve mobility questions that we have right now? Traffic-packed cities, air pollution, stuff like this.
So they might, but I think it's much more complicated than a lot of the hype would have you believe. For example, we've had autonomous transportation for 100 years. It's called a taxi. Okay, yeah. Okay. And the only difference between that and a self-driving car, in one way of looking at it, is it costs more to have what does Uber say? The dude in the front, right? It costs more to have the driver in the front. So when you ask about these tough mobility questions, sure, there are a lot of interesting things about a self-driving car. It can go park itself and get itself out of the way, or leave the city and park outside. There's a lot of cool things you can do, but thinking that autonomy is this magic wand that will change people's behavior, it doesn't make sense. If right now, and I know there's a trend to change, but it's still a lot of places, only one person rides in a taxi or a shared vehicle. And removing the driver and making it cheaper, I don't see how that makes people want to start sharing, right?
Yeah, yeah.
You know, it's,
Yeah.
wait a minute, it's cheaper, so why would I want to save even more money by sharing?
Yeah.
Now, there's cultural imperatives that will change that. There's lots of ways to change it, but simply making things autonomous isn't a magic wand that's going to solve all mobility problems. It's a much harder problem. We're going to have to deal with it as a society. I mean, when was the last time that technologists solved a social problem effectively?
Good question.
They can help,
Yeah.
they can make a positive contribution, but you need more than just the technology to make a social problem go away.
Okay, then of course we can, look forward to autonomous driving, but we still need to change people's mind, sharing cars, that cars are not the only solution, also trains.
Yeah, public transportation, all those things.
Yes.
So I think self-driving cars can be an effective component of solving mobility problems, but just deploying the technology is not going to make it happen by itself.
Okay. Really last question.
Okay.
How do you like the conferences so far?
Oh, I think the conference is great. I think I've been in the safety track this morning, and we're having some really first-rate, well-known speakers. I walked in the room and was like, I know all these people. That's cool.
That is
I've heard of
good.
these people, and I haven't done the autonomy section yet, but I expect it also have really good talks.
Thank you very much for this quick talk, Philip. And yeah, enjoy the rest of the conference.
Okay, thanks
Thank
a
you.
lot.